The other thing that we're going to change as we go along here is when the ball comes in, nothing is going to distort it. So it's a ball, 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 ball till we get to the favor, and then it squishes on number 7. And then we're going to go back to the ball on 8, and then we stretch, and then we recover coming back up, just as we did in the perpetual ball bounce. And then as it comes down, it turns back into a ball, comes down, and here we have the ball there, then the squish position. Then we're going to do a little bit of a stretch here, taking out that halfway circle part. We'll go directly to the stretch, then it recovers back to the circle, 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 circle as it comes down. But each time we bounce, it's not going to be as squished because there's not as much energy pushing down on the ball. So when it comes from here to here, we'll get a bit of a squish. Then the second one will get slightly less squish. Next one will get even less squish. And the stretch will also be less as it comes up. So it's losing energy both in its height and its distance, but also the deformation that takes place in the ball itself. Right? So now up to our next ball bounce here, we're going to go to a halfway position here, and then a quarter, but not an eighth. Then up to our high point. So it's 28, 29 is here, and 30 is the key on G. Then a halfway and a quarter, so it's 31, 32, and the low point at H is 33. Then in here, we just go to halves to our high point, and a half on this side here to our low point. So it's 34, 35 is the high point key, 36 is the halfway, and J is 37, the key at the bottom. All right. Now, the next thing we have to do is we have to get the ball to roll to a stop over here. So let's say we've taken from this distance here to this distance here. We follow the same rule that we've always followed, which is the halfway position. You have to drop a halfway in between in here. And then we want it to ease into a stop on the end. So we put in a quarter and an eighth and a 16th. Would give us a nice slow in there. But the next thing that we have to consider is what's the overall speed as it moves across this way. So as it goes up to the top there, it's slowing into that high point position, but it's also slowing as it goes across this way. And we have to look at the height and the distance over here. So our position on the surface, if we just drop each of these drawings down here, will give us how far the ball is traveling in a horizontal direction. Now what you'll notice is, as it moves from this position to this position to this position here, it's slightly getting smaller right in there between these two here, but they're basically very close to the same distance. Notice what happens between 37 and this next one here. See the difference between 36 and 37? And then this one here? What happens if we shoot that? What will happen to the ball?
The ball will just disappear and then pop.
No, no. If we had a ball here for 36, we had one for 37.
Doesn't go up.
No, it doesn't go up. We just want it to roll here.
Yeah.
But what about the speed?
It speeds up and
It's going to speed up and then slow down,
and then slow down.
right? Because your distance here is the same, pretty much the same, and then all of a sudden it goes vroom, and then it slows down. So it'll come in like this, it'll go boing, 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 vroom, and then stop. So we don't want that. What we want is we want our distance here to be pretty much the same, and then it begins to slow down. So what we want to do is we want to drop another in between in there. So the general distances in here are all the same. Now, what I've drawn in here as far as the arcs and everything go, they're malleable. You can shift these around a little bit if you want to. All right, it's not like they're carved in stone. But the idea here is that you must make sure, and this is really important, you must make sure that these distances here remain fairly consistent, and then they begin to slow down. How many drawings you drop in here is completely up to you. Right? So what I've got here is I've got 1, 2, 3, 4, 5, 6, and then 7 into the final position there. What I could do is I could drop in another one in there, and then another one in there. So that if you look at it enlarged, this does not represent the distance that it's traveling. This just represents the breakdown of the drawings. So I'd have a halfway here. So this is 37 here. So it's just to be able to make it clear. We'd have quarters in here, and then we drop in a half, another half, another half, and another half. Okay? So you can see as I get this small distance here, this is the actual distance that it'll travel on the paper. But you can see once I get into here, if I start dropping in more in-betweens in there, you can't tell. The distance is so small, so it's difficult to see. So expand out your timing chart so that you can see it. But if the distance on your timing chart in real space that the ball is actually physically going to move in gets to the point where you can barely even see the difference between the lines, means you should give up at that point and just stop moving it, because it's the thickness of your pencil. Who's going to notice that distance? It's hardly moving at all. It's just going to sit there and wobble. All right? So you got to make sure that you're actually physically moving it someplace. Once you start replicating the lines over top of each other, it means it's still in the same spot. It's just hovering there. Right? So there's a point where you give up on how many in-betweens you put in to slow it in. But the key is that if you're traveling this speed over here, you have to maintain that over here and then descend. Now, that doesn't mean that I can't do this. I could also take from 37 here. If I put my actual distance timing chart here like this, doesn't mean that I can't do this. Shorten up the distance here to here instead. Meaning that the ball doesn't roll as far. Okay? So, it's exactly the same thing as taking the ball from here and dropping it to here and then bringing it up to here. I don't have to bring it to there. I could bring it to here if I wanted to. I could bring it almost to the same height if I wanted to. It just depends on what type of ball this is. If this was a ping pong ball, the height would pretty much maintain itself for several bounces and then slowly start to lose its energy, right? That if this was like that lead ball that I had, or not quite a lead ball, let's say it was an actual hockey ball that didn't have the lead in it, it might do 3 bounces. So to come in, boom, boom, boom. Or let's say it was a bowling ball. Your path of action might be like this. You'd come in like this and go boom, 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 and then roll to a stop. So the amount of energy that's being lost because of the surface tension and the weight of it is great. There's a huge loss there where it only has this tiny little bounce and another little bounce. So it's not like it has to be 1/2, 1/4, 1 3/4, 1/3, or anything like that. It's whatever you want it to be, because it's your ball, right? So what I'm saying here is, this is the general guide. This is basically what I would like you to follow, all right? If you want to make little adjustments to this, this is fine for me. If you want to change the distance that it rolls here, that's fine with me as well, all right? Just so long as the distance remains consistent and it rolls to a nice even stop. Right? So if I change my distance to here instead, then I drop in halfway in between. You can see that the distance there is still greater. I still have to drop another in between in there, and then one over here, then another one here, here, here. So I still end up with the same number of drawings that I had here. It just means that it stops faster. Right? Or does it? If it's the same number of drawings, but the distance is shorter, does it stop faster? No, it stops at the same time, in time. It just doesn't move as far. Okay, which is exactly the same thing that we said over here. You could make the ball bounce to here and still put in the same number of drawings. It still takes the same amount of time for it to bounce. It's just that it's bouncing less. Right? So here's where now we're getting into the realm with this piece of animation. Is I'm not going to dictate to you it has to bounce this much. I'm going to let you decide how much it's going to bounce. You're in control of this now. You're the animator. You make the decisions. Okay? Ugh. Scary proposition, eh? It's simple though. It's simple. We've already plotted it all out. So now, let's go to our first drawings. We're going to do our first key now, which is drawing number 1, which is basically the ball that we had over here. We'll just draw that ball in that position. So down at the bottom here, write number 1, because it's your first key drawing. And then we're just going to trace this ball off here. Like that. Now, according to our path of action guide, number 7 is going to be our next key position. And that's where the ball touches the ground. So our next drawing is number 7. It's a key, so we circle it. And find your contact point on the surface. That's the surface that it's going to hit. And this is where we draw the squished ball position. So now remember, this is a toonie, or a loonie. I don't think I have any in my pocket. Wait, I do. Ta-da! There's my toonie right there. So if this is the size of this one there, ooh, look at how accurate that is. Isn't that amazing? It's like the exact same size. I'm good. So if we bring this ball here, and if I just trace that off very, very lightly, just as a guide to say, here's my overall volume. That's the volume of my toonie. Then I have to make sure that if I'm going to squish it that much down to there, that the volume of the ball has to go out on either side. So you can see clearly that the volume that I placed out here on either side does not work. Okay. What it looks like I've done is it looks like I've taken my toonie and drawn it like this. So it's going back in perspective. Okay, it's added a little bit of width to it, but it looks like an ellipse going off that way, so it doesn't have the same volume. But you can see that the way the ellipses work, it's difficult to hold it here, but the way I hold the circle like this, if I turn it like that on the major axis line, you can see the width of my coin is not changing. It's not shrinking at all. The distance here on the minor axis line is the part that's shrinking, right? So with this ellipse, we have to make sure that we're thinking of the volume. It's not just an ellipse template, that we're changing this circle into an ellipse. So we're shrinking it here, but we've got to add that volume on the sides because it's being displaced. So we've got to puff this out on either side here to make sure that it looks.
Where is the center?
Sorry, the center?
Yeah.
Well, the center would be right in the center. There. Now, if you want to be artsy-fartsy about this, and be a little bit more, not artsy-fartsy, I guess is the wrong term, but if you want to be more realistic about it, you could do this. You draw your ball squished, but flatten the bottom just a little bit more. So you're not getting as much squish on either side, you're getting a compression, but the compression is taking place on the surface. So you could do something like that. And if you really wanted to be cute, you could even do something like this. Or put a little wrinkle in it like it's smacked on the ground there. Now, what does that do to the overall action? It causes something to happen in the action. What does that look like to you? Like, it's a household item that you use in your bathroom. It looks like a plunger, doesn't it? Okay, it looks like the head of a plunger. And plungers basically use suction in order to get whatever is stuck in the toilet out. It forces out the water. So what ends up happening is that looks like a little suction cup that's stuck on the ground. Okay, so it's going to have the effect that it's going to fall in and go when it pops up off the ground. It's going to have that feel to it, like it's stuck. So visually, it's going to have a different effect than this will. Right? That'll have more of a springy boing to it, whereas this will feel like it's stuck. Right? So you have to be aware that the way you draw your drawing will also be affected. So some of you, I mentioned this in the first class when we did the perpetual ball bounce. Remember what I said I didn't want to see? Remember the different types of balls I said? I said I didn't want to see footballs, so I didn't want to see your ellipses looking like this with little points on the ends. Okay. I also didn't want to see loaves of bread like that, where they're squared off. And I also didn't want to see potato rocks. Okay. But several people had a very hard time drawing their spheres and cylinders, or sorry, their ellipses, and they ended up looking like that. Okay. If you draw it like that, it's going to look like it's a rock hitting the ground. Right? It'll have the visual impact because you've drawn a visual representation to say this is a rock. And so when it does something completely different, if you follow what I did in this overall timing here, it's going to say something different if you make it look like that. It'll be doing something that it shouldn't be doing because rocks don't bounce like this with this kind of timing. Okay, so it creates this visual story that the audience will go, that doesn't make sense. It's a rock, but it's bouncing like a rubber ball. What's up with that? Okay, they won't believe it. They won't accept it. So you've got to be very, very careful. Okay, visual icons are very, very strong. And even though we're just dealing with something really simple as a circle, if you change it into something else, it will say something different. Right? So you have to be very, very careful. So if you choose to go this route here, it will do something different to your animation. So be careful with it. If you want to do it, you can, but you got to make sure that it works properly. All right, so this is on a little bit of a slant. You can see that my ellipse is off, and that's because I'm drawing it sideways and upside down from where I'm sitting here. I really should cut this down more like that. Okay, so there's our second key position. So flipping these two drawings, ta-da, our ball is impacting on the ground. Now what we want to do is we want to go to our next key position, which is number 13, up at the high point here. Now, the lines that I've drawn here, you can treat them one of two different ways, or you can combine the two ways differently. All this is I'm suggesting this is your path of action. You will ultimately, like I'm not going to create a template, you can't trace off my drawings. What you're doing right now at your desk is your variation of this. So whatever point you've chosen it to come in, whatever point you've chosen it to hit at the bottom there, and whatever point you choose to make this a high point will be ultimately up to you. So what I'm saying is that the guides that I've drawn here are not necessarily carved in stone. They're simply a reference to say, here's basically what it's doing. You choose the final position of it. So in this first drawing here, you'll notice that the ellipse or the circle that I've drawn, this center of my path of action falls into the center of the circle. Whereas down at the bottom here, this point right here is actually the contact point on the surface. So it doesn't mean the same thing. It simply means I'm going from here to here, and I got to drop a certain number of drawings in between. So now when we go to our high point here, what does this intersection point between our path of action and this line that I've drawn there, is that the center of the ball, or is it the bottom of the ball? I don't care. Make it whichever one you want. Okay? It's just simply saying it's going up in the air, and here's the high point of it. So if you choose to put your circle like that, it simply means that the ball is going to be slightly higher. If you put it directly in the center, it's slightly lower. If you decide to put it down here, it's even lower still. Right?
If we choose it should be lower at the point.
Yep.
The next process should be the lower.
Yeah, it'll be lower again. So if you're putting it down here, then the next one should be there. The next one should be here. But see what happens? Now the ball, my coin, is touching the surface.
Yes.
So it's not actually going up in the air. So therefore my surface is interfering with my high point. So maybe you should make it like that. Okay? So it goes surface to surface like that. And then as it comes down here, it goes into the center to the surface, center to the high point. Okay? So your actual path of action, if this is the point of the high point right here, let me just trace this off like this.
But for first one was the center.
Yeah, the first one was the center. And I'm just saying it's whatever you want it to be, but it has to be logical. So if I go center to center, then that's going to modify, or bottom to bottom on this one here, means it's going to go from here up to here. Then I have to modify the positioning of all my other drawings here in order to match it up.
Yeah.
Okay? So you just have to be consistent with what it is that you're doing, right? I'll leave it up to you. If you want to switch it so that it's the middle here on these parts, but then as you come down here it begins to go to the bottom, then do that as well. Okay? I don't care. Just make it work.